Hello guys, good morning. Welcome to another episode of Xa Talk Show. So today we are going to do a coding challenge. I'm going to code Wolfram language. Okay, let's start Wolfram language. Wolfram. Okay, I'm gonna code Wolfram language to answer this George's coding challenge. And I have start a new Wolfram language file and evaluate it, start it, and let me explain. Okay, so let's magnify so you can see. So George posted a coding challenge to our Discord forum, and here it is. I'm gonna read it for you. Okay, so the coding challenge, and I have a bet with Dion, and actually right now we have already several solutions by different people. You know, we have several people posted the solution. Triangle, the idiot. Okay, and several people posted the solution in different languages. Oh yeah, Dion, Zephyr, and Triangle, and several people. So I claim I'm going to code this today, right now, in Wolfram language, and I claim my code is gonna be the shortest than them all. Python, Ruby, JavaScript, or whatever, shortest, but also the fastest. Okay, the most fast, speedy, the most performant. That's the word, performant. Okay, than all the solutions. So what is the challenge? Okay, so let's let's read the challenge, and I have a bet with Dion. Okay, I have a bet with Dion. So Dion is gonna bet whether my program is gonna be the shortest and fastest. And so, okay, let's begin. So the coding problem is that create a function such that when given an array of numbers, returns the number that appears an odd amount of times. Okay, so only one number will ever appear an odd number of times. So there's a unique solution, and there will always be one number that appears an odd number of times. Okay, so given an array or a list, whatever your language calls it, a list, and it's a list, a bunch of numbers, and many numbers occur several times. Okay, so you want to find one of the item, that's a number that occurs an odd number of times. Okay, and and that's unique. You know, there's a unique answer. So here's some example solutions. I mean, the specification of the problem. Okay, and try to think of the shortest solution. That's the fun part. You know, that's the fun part of the so-called leet code. Shortest solution, and the shortest or the most elegant and the fastest. Those are all good criterions. Post your solution in thread. Okay, so okay, I'm gonna start to do it. Okay, so so Wolfram language. So let's save this in desktop. Let's name it getart. Okay, getart.mb. That's a Wolfram notebook. So okay, so this might take me 30 minutes. I'm gonna try to do it as fast as possible, but 30 minutes, or I'm gonna try to be shortest and fastest, then all the others, then Python, then Python, Ruby, JavaScript, or even Golang. Now I'm not sure if you code it in C, I'm not sure I can beat it. I mean, even in Golang, possibly. Okay, I don't know for sure. Okay, but I'm gonna try. Maybe 30 minutes to 40, or maybe an hour. So let's begin. So you're gonna watch. You're just gonna watch me coding. Okay, and meanwhile, if you like, you might try to do it. It's probably going to be boring for you, because I'm just gonna go technical on Wolfram language. Okay, so I'm gonna begin now. So you want to given a list. So okay, so let's just begin. X list equals to something. Okay, and let's for example. So you also want to make sure you handle special cases, like an array of a single item, right? So for example, let's see. So here is an example from George. So let me start my solution here. Okay, so start a Wolfram language code block. Okay, and this is the Wolfram language solution. Okay, let's just do it. Okay, and let's start to code Wolfram language. Okay, so Wolfram language, so X list, let's define the input. Okay, so that's the input. So in this case 7, because 7 occurs 3 times, 7 7 7, so the solution is 7. So you want to define a function, let's say get odd. Okay, get odd is a function, and okay, let's just let me code it. Wolfram, I'm using XAR Wolfram mod in JavaScript. I mean XAR Wolfram mod in Emacs. That's my own mod. You can find, if you just search it, you'll find it on GitHub. XAR Wolfram mod. Then I can evaluate it here in Emacs, or I can paste it. I'm gonna paste it in Notebook. Okay. So, but I can type it faster in Emacs. So that's why I'm doing it here. So the function will take a input. Okay. So input will be, let's name it X list. Okay. And here's the function body. Okay, body. Okay, so okay, I have to think about it. So define a function. So this function takes a list, and the output is a single number. That's the item that occurs an odd number of times. So the output is a number, and it's a part of the list, an item in the list. Okay, so so you want to count. So let me write some notes for myself. Okay, so actually, let's go back here. So what the plan of the algorithm, this is the process of how I code. Different people have different styles. I tend to be, first of all, a logical analysis. Some people start to code right away, trial and error, which is different styles. So first of all, I want to so count. So basically you want to count number of occurrence for each and every item. Return the item that's odd count. Okay, so essentially count. So you have to count. Okay, so you can, so I'm thinking whether you can abort in the middle once you find the answer, but I don't think so, because you have to cover you have to count everything. So yeah, because otherwise you have to go all the way till the end of the list. Otherwise, you wouldn't know if that occurred. Yes, okay. So count the number of occurrence for each and every item. So for every item, so for every unique item, you have to count it. So one of the most common intuitive solution is to build a dictionary or hash table. So every time you take a number, see if it already exists in your hash table, in your dictionary. If not, you add it with a value of 1. If it already exists, you add it. If it already exists, you increase the count by 1. So after you do that, you got a hash table. Then you go through the hash table. Then you go through the hash table and find the one whose value is 1. Okay, so let's write it down. So it's so it's clear to everyone who come to watch the video. So okay, most intuitive algorithm. Okay, build a hash table, build a dictionary for by go through the list for each item, add to the hash if it already exists, increase value by 1, else add to hash with value of 1. Okay, so that is the algorithm. Okay, so that's the most intuitive algorithm. We can do that in Wolfram language, but I think I got better way. So that algorithm is probably okay. Now that this algorithm is probably how you're gonna do it in every other language. This is the most common. So now let's think about, is there some kind of shortcut, like a trick or a mathematical formula to do this? Another way, for example, if you can, is that you get, you try to get all the unique, if you can, maybe there's a, if it's very fast to get all the unique items in the list, because this list is going to be lots of numbers, and most of them will not be unique because each item will happen several times, right? By the spec. So the unique item will be actually a small subset of the list. Okay, so if you can get the unique item, the unique items, you still have to count it. Okay, so maybe let's just work. Let's just brainstorming. Okay, another way. This is probably not a good algorithm. Not efficient. Get all unique items in the list, because most of the time, assuming the list is random-ish, most of the time the unique items will be a small subset of the list. Okay, of the list. Okay, then you still need to count each. Then you still need to count the occurrence of each unique item. Okay, then that kind of made it pointless, because is there some kind of magical way to okay, so let's go on to the next idea. So another way to solve this is you can reorder them. That's right. You can sort the whole list, but sort is fairly expensive. Yeah, probably not a good solution. Sort the whole list. The advantage of a sorted list to begin with is that you can, once you find a different number, then you know that is it, the number of the occurrences of the particular item. Okay, being that when you go through the list and when you see a different number, then you know that the current number no longer occur. In other words, you can find the occurrences by partition the list into sublists. Then you just count the length of each sublist. But you do need the algorithm that compares differences between items. Okay, so that's another way. I don't think these ways are faster than the simplest the hash table solution. Okay, so that's enough thinking. Let's start to, Wolfram language has lots of built-in functions. This problem, when I saw it, I'm thinking there's already built-in function for it. Probably something like that. Okay, let me try to find it. Okay, tally. There it is, a function tally. Okay, tallies the elements in list, listing all the distinct element together with their number. That's it. That is it. That is the solution. Okay, let's do it. We don't. Okay, tally and XX. Okay, so XX is the input. So yeah. So okay. So that's already the solution, isn't it? Okay, let's run it. Let's see what we get. Okay, function. Okay, so let's add a semicolon. So we already got the output here. So the output is this. So 1 occurs twice, 7 occurs 3 times, 3 occurs twice. Is that right? That's correct. Then once you get this, then all you have to do is you want get the item such that the second element is odd. Okay, so now, yeah, this is the solution. I think I'm gonna win the bet. Okay, so Wolfram language, let's go to my own Wolfram language tutorial. You know, I'm promoting Wolfram language. Wolfram language, you know, Wolfram Research is donating to me, sponsoring, you know, my videos. So I have written a tutorial, the whole, you know, I've been coding Wolfram language since 1992. And it is my favorite language. I've been coding it for over 10 years, since 1992, every day, you know. And so I want to, yeah, so let's look at my tutorial. You know, I've been working on it again. So right now we want to get the item in a list such that the second element is an odd number. Okay, so here's all the possible functions to get the list. So you can use pattern matching, which is in general much slower. So I don't want to use pattern matching. Or you can use I can try both ways. So pattern matching is a solution. Then the other solution is just go through each one and apply a function. Select. Okay, so here is. So if you want to get parts of an expression by a function, you can use select. You know, you give it a filter function. You know, there's a built-in. So you know, that's, you know, we just copy and paste. Okay, let me show you. Okay, so select is one way. So let me so tally. So select the tally result. Then here will be a function. Okay, I have a shortcut. So this is powerful Wolfram shortcut. I'm not gonna explain. Well, okay. Actually, so let's, okay, first of all, let's remove this part there. Okay, let's not use the shortcut because the shortcut is hard to understand for a lot of people. So let's use, yeah, but however, we are doing a bet of the shortest program. So actually, I do want to use the shortcut. But let me do the full form first. Okay, the function, then the argument. So what is this even queue? Okay, so we want to test the second argument. So second argument. Oh God, so if you take a element, that's gonna be much slower. So actually, maybe the pattern matching is faster. Let's try it, okay? So the second element is odd, okay? There it is, okay? So let me show you what's going on. Clean the code. Okay, so let me explain. You know, you guys, you know, Wolfram language is just like Lisp. So here is a function already, so remove that. So tally, first of all, we get tally, and then we select. Okay, select takes two arguments. First of the first one is the data, okay. The second one is a function, so this function is gonna be odd and second argument, okay. So function, so this pound sign stand for the input of the function. So we take the second part and we check if it's odd. Then if it is, then return it. Okay, but the thing, this will work, but however, it's not the most efficient because we know that this problem, there's only one odd, one of the item that occur odd number of times. So once we find that, we do not select the other ones. So this is not the most efficient, but let's just run it. So to make sure it's correct, okay. So get odd x list, okay, let's run it. 7.3, you see, that's a result. You see, this is a correct result, okay. Here is the correct result. Let's put it here, okay. Let's put it here. 7.3, okay. In fact, actually, we need to return a number, so we don't want the list. So we want to. So once you select it, then you want to take the first element of the first element, okay? Because here is the output, that's a nested list. You want to take the first element, which is this list, then you want to take the first element, that's 7. So let's run it again. Okay, so you forgot the unique parts, okay? So there, run it. There it is, you see, 7, okay? So this is our first solution, okay? That's not efficient. Let's do another one. Okay, let me run this in Wolfram language so you can see. Let's run this in Notebook so you can see. Run it, you see 7, okay? Let's put it here. Okay, so now let's make it faster. Now we're gonna do the timing. We're gonna write the command to do timing, and we're gonna write several solutions. Okay, so this is the first solution. Okay, get odd 1, get odd 1. So that's second solution. Now we know that there's only one occurrence, so let's do a pattern matching. Okay, pattern matching. Okay, so the function will be, you are given a list that's a result of tally. Okay, let me write it out so that you can understand. Result of tally is that, okay? Okay, let's so this way you can see result of tally essentially is the solution. Okay, so we can do that will return true. You can let's run it. Yeah, you see true. You see. Okay, so first solution, then second solution, let's use pattern matching. So when you use so you are given a list like that. Now you want to select an element such that the second element is odd. Now you want to do this by pattern matching. Okay, so how do you do that? Yeah, so let's go back to pattern matching. You use the cases. Okay, so let's do it here. So second solution. So you don't say select. Okay, so let me copy. So you want to say cases. Okay, cases. The first element is the data. The second part is a pattern. Right, the second part is a pattern. So in this case, we're gonna be, the pattern is gonna be a list, and x anything. Okay, so a list x x is a number. The second part is well, actually x anything. You know, we don't want to do extra computation because we need this to be as fast as possible. The second part is gonna be odd. So underscore means anything with a condition. Okay, with a condition. So we want to do pattern matching by applying a function. So we are doing both, kind of a pattern such that this function returns true. Okay, so pattern syntax. So let's go to pattern syntax. So yeah, test. Okay, test is odd q. Okay. Okay, so this is the pattern matching solution. Okay, so let's do it here. Hello guys. Hello Reaper. PHP wins. Reaper has a PHP solution. We're gonna check out. Well, not in live stream, but you know, we're gonna check out all the solutions to see who is faster. Okay, run it. Pattern matching. Okay, again true. You see, it selected 7, so that's correct. So I need to go faster. Okay, so you need once you get the result, you need to take that. Okay, run it. Okay, 7 is true. Okay, let's just say equals 7. That's true. Run it. You see, true. Fantastic. So we have 2 solutions now. But both of them are not the most efficient because they actually go through all items. We want a solution such that once you get an element that the second part is odd, stop. Okay, so actually I wonder if that's already part of the tally function. So is there a, let's see, tally, maybe there's an option. So indeed there's an option. The second argument, test, used test to determine whether a pair of elements should be considered equivalent. Okay, we don't want the test. Give a list of the first representatives of each equivalent classes together with their multiplicities. No. Okay, we want an option such that it will just select. Okay, so is there an option? So one easy way to find out is you type options. Okay, options, and give the function name tally to see if there's any option. No. Okay, so we have to do this manually. Okay, so second solution, third solution. Okay, let's select by function, but exit when first found. Okay, So select by function. Yeah, so let's copy that. Third solution, okay. Select by a function, this function, but once you find it, immediately exit. So in that case, you don't want to use select, because select doesn't immediately exit. Okay, so okay, let's check if there's an option in select. Pick out all elements E1 of list for which criteria 1 is true. There it is. Pick out the first n elements for which criteria is true. So all you have to do is give this n to 1. This is fantastic. So select list criterion and n. Okay, so select. Okay, so let's clean this up so you can see easy. So you can see select. So select a list, a criterion. Yeah, the criterion, and third argument 1. as soon as you find it, return it. Okay, so now let's do. This is gonna be my submission. Okay, let's run it. Let's run it. 7.3, fantastic. So we still need this extraction. Okay, let's show the pink window. So let's run. Let's copy that. Do it. Select. Do it. True. 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 All true. So all these solutions are correct. Okay, and this solution is the fastest. Yeah. Or you need this one. Okay. I think that's actually that's going to be my submission. So we copy that. Let's run this in Wolfram language so you can see. You know, it automatically colors and all that. So you see, run it, it's all true. So this solution works, okay? What about some special cases, you know, edge cases? So when there's one element, it should work. Yeah. Okay, my solution, this should be my solution, okay? Okay, let me think about what else. So any questions, any comments? Let me take a break then. How long have I been? 30 minutes, 40 minutes. So we did 30 minutes. Maybe I should stop now for this video because you know, it's better for the video to be short. Then I'm gonna work offline to see in what ways I can squeeze this into more tight code. You know, in fact, we can optimize already. So we can, let me show you, okay? So fourth solution, remember we want the shortest code possible. So this can be shortened a lot, okay? So for example, let me try, okay? So function, so this function you can use a short, let me show you, okay? Fourth solution, okay? 4, and this function part we can rewrite it so that yeah, so you see this function can be written like that, okay? So it's even shorter. But let me tell you, okay, so this should be faster. I mean, not faster, but shorter. But let me give you another fifth version. Let's also keep the document. Same as third solution, but shorter syntax, okay? Now the fifth solution is going to be okay. same as fourth, but faster, okay? Now, how do you make it faster? Because every time you extract an element, that's actually slow. Okay, so what you want to do is actually transpose the tally. Okay, let me show you. Let me explain. Let me explain what's going on. So you have a, okay, let me explain, okay? So you have a matrix, right? Now you can transpose it. Transpose means you're gonna have 1, 7, 3. Then the second part is going to be 2, 3, 2. You see, that's transposition. You have a 2 by 3 matrix. Now it becomes 3 by 2 matrix. So once you transpose it, all you have to do is you want to find the first row. Actually, you want to find the second row. You want to find the odd number in it. Okay, get the odd number there. So in this case, it's a second item. Then you take the second item from the first row. That's your answer. Okay, so that is what we are going to do here. So you're gonna transpose. Okay, this is gonna be faster even, because transposition is a extremely fast operation in Wolfram language, because Wolfram language is like a list. I mean, it's like a Lisp language. So it has lots of operations that works on a entire rectangular nested list the most efficient way, faster than you can do in C, because the data structure is structured in such a way to optimize this kind of operation. Because linear algebra, you need to do lots of these. So transposition, so we're gonna transpose this tally result, and then we're gonna do a select. Okay, so let me write it. Okay, so transpose the tally result, then we're gonna select this thing from this result, and so okay, transpose first. Okay, so let's do it here. You transpose it, then you take the second. So you transpose it. You take the second element. Okay, so you take the second element. Okay, then you select. Right? So then you select from there. You want to and the criteria is just odd. Okay, that's all. That's all there it is, odd. Then you only want the first one. Okay, so once you get that, let's assign it to when you do assignment, it slows things down. We are really trying to squeeze speed here. So you transpose, you take the odd, and only the first occurrence of it. Then you got the number, which should be the 3. Okay, but you want the index here. You want the index. You don't want the number. You want the index of this thing. Okay, so is there a select indexed? Date selectable, select cell. I don't think so. Select first. Oh. Okay. So instead of, we shorten it again. So instead of select, give 3 argument, we just say select first. Okay. Yeah. So that's gonna be another solution. So anyway, select first. Trap selection, what is that? Trap selection, okay, that's some system. Selection, select, evaluate, what is that? replaces the current selection in a notebook. Okay, that's more interactive thing. That's a notebook programming, like when if you program org-mod files, that's what those are. Selection, evaluate, just like Emacs. You can like manipulate the notebook. So I don't think so. Okay, we are kind of getting out of focus. So can I do this quickly? So fifth solution, same as first but faster. So once you transpose, you get a number, but you don't want the number, you want the index of this number. Okay, so you don't want to select. So you don't want to select, you want the index of that number. So okay, I think I'm kind of stuck. And this is getting more complicated. Okay, let me just run it so you can see what's going on. Okay. So select first. Don't need that anymore. Okay. So this is the fifth solution. Fourth solution. Run it. True, 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 false. So yeah, the last one is not done yet. Okay, so you see it returns 3, which is the correct answer. But we need the index. We need the index, not the. Okay, anyway, now we have 4 solutions. Now let's modify them. So we don't use select, we use select first. Okay, so let's try this one first. Instead of select, let's say select first. Okay, we don't need that. Run it. Part specification. Okay, so wait. Run it. Oh, okay, yeah. So if you use select first, then so you just need the first one. So we don't, you can just say first. More shortcut. Run it. Correct. 77773. Okay. So that makes it. Yeah, this is the fastest. Okay, so let's replace all these previous by just that. Okay, run it. You see, all correct. Now we can also do this and do that. So we run it. Okay, so we have all these solutions, but the fifth solution I still need to work on. Okay, I think maybe that's it. How long have I been doing? 50 minutes. Okay. Yeah, so let's run them in Wolfram language. Okay, let's run them here. Lots of, let's shrink it a little bit. Okay, run it. So it's all 7. So the only one we still need to work on is the solution number 5. I hope I can do it in this live stream. So So you need the index. You need to go through it. You need to get the index number, but you don't want to use anything that's like map because you only want to get the first occurrence then exit. So the first occurrence then exit. So in that case, so this is a problem. So given the list, you want to select by some criteria, and the result should be the index of the item, not the item itself. That is the problem we are trying to solve. So okay, so this problem belongs to get an element out of a list. No, not really. Get the index of a list. That's right. You want to get the occurrence, right? So you want to get the index where certain criteria occurs, okay, and only the first one. So once you find it, exit immediately. So in that case, so let's look at here. Count by pattern. Actually, there are so many Wolfram language solutions. You can there's also count. Count. Okay, so let's go back. Position. Exactly. Position is what we want, okay? Position, you give it a pattern, it returns the position, kind of like an index. If the list is flat, it returns the index, right? Yeah, position is what we want. So position we can use. Now let's see if there's something more convenient. Sort by reverse, rotate right, no. Ordering, no. Join, union, intersection, refill, no. Partition, no. Split by, no. Gather is that you group a list of items into sublists such that they match some criteria, such as, gather all the same items, right? So before we were thinking of an algorithm that rearrange the list to like sort. So gather does that without actually sorting. So gather does that. Permutation, minimum, maximum, flatten, transpose, pad left. So is there let me think, is there a way? Okay, position is our solution. Let's just get on. Let's finish this solution, then that's it for the video. So fifth solution. So you transpose it, then you don't want to select first. You transpose, okay. Then so you transpose first. Then you want to call position. You call position on it. The first element, the first argument is the expression there. The second argument is a pattern. So the pattern will be this one. This is a pattern underscore that matches anything but must satisfy this function. Okay. Okay. So that's the pattern. And then level spec. Okay, level spec is I'm awesome. Thank you. So level spec, Wolfram language, when you have a list, in most languages, when you have a list, you have a function like map, that can apply a function to every element in a list. But however, if you have a tree or matrix, you want to apply just to rows or the leaves of the tree. then in all the other languages, Python, Ruby, JavaScript, you cannot do it. In fact, it's very painful to do it because their lists are generally flat, But Wolfram language lists are almost always arbitrarily nested, so you have lots of nesting. So almost every function that applies to a list has a option level spec that can specify you want to apply the function specifically to specific level. Like, for example, when you traverse a directory, first, the depth, Unix would call it depth. But here, the level spec can be just one level or a range of levels, or -1 means all the leaves of a tree. So here you can specify a level spec. The levels will be just 1. You see, so here is the level spec, okay? So infinity level n only, so the level will be 1, okay, just level 1. Then the last argument is 1 because we want to chicken. Thank you, Ripper. money is everything. Thank you. So I think that's it, okay? So get the first n object, okay? So let's do that. Okay, let's run it. 2, that's what we want. So we got the result of 2. Fantastic. Now, once we got the 2, okay, we need a variable. We need to save this. Okay, so this is gonna be more work. Okay, so now let's declare a local variable. Okay, a local variable module. That's how you define a local variable. So module is like Lisp's let. Okay, so this variable will be that. Okay, so x data. Okay, so x data equals to that. Okay, then whatever body. Okay, the body is gonna be this whole thing. Okay, so this is how you define local variables. Okay, so local variables. Now you have this transpose. This is the data. Okay, yeah, okay, so let's do something here. So x data, then do that, then get the position. So this position, let's run it. Okay, so you can see the result is that now once you get that, you want to, okay, so this is gonna be longer code. Okay, so data, you want to data the first element. Okay, so let's actually, okay, the first element of the data, then you want to extract this. Okay, actually, okay, this code you wouldn't understand, but that's it. I think that's it. Run it. Okay, we got some error. So right, so you want yeah, so okay, I know what's going on. So hold on a second. So the first of the data, so you want to apply okay, I'm not gonna explain because it's gonna take too much. Yeah, let's be so let's do this fast. Okay, so you get the position, let's write it out. Let's remember this returns that. Okay, so you get that, and you want to, this is gonna be fastest, but the code is much longer. Okay, So the first part of the data, and now you want to essentially extract that. Okay, so let me look up. Almost done, almost. So I need to look up parts. Okay, get elements, the part syntax. So if you do that, okay, that returns the multiple parts. So you want to get first element, then the first. Okay, so you want to say part position, then you want to say the first element of that and the first element of that. Okay, then actually, okay, this part is incomprehensible to you guys, I suppose. That's it. That's, wait, what? Yeah, so I think that's it. Run it. There it is. This, I believe, is the fastest solution. Okay, this is the fastest solution. So, you know, let's copy them to Wolfram language, to the notebook, so we can see the result here. So we have Art1, Art2, Art3, Art4, 5 solutions. Okay, run it. Fantastic, they all worked. Yeah, and I believe the number 5 solution is the fastest, the fastest, and we can clean up the code. So let's say 6th solution, we can make it shorter. Okay, now let's try to make it shorter. There's yeah. Okay, so that, make it one line. Okay, so that, then okay, that make the whole thing one line. Okay, 6th solution. Okay, run it. Yep, it works. Copy the whole thing, paste it here, run it. You see all 7. We have 1, 2, 3, 4, 5, 6 solutions. Okay, now of course this can be shorter too. This can be made even shorter. Yeah, yep. So 7th solution. Wait, let's clean up the okay, 7th solution, same as 6, but shorter. Okay, even shorter. Okay, so the function, yeah, so the function will be okay, there it is, function. Okay, yep. So 7th solution, run it. Oh, wait, did we define? Oh yeah, we forgot to change the name. 7. Run it. Fantastic. Backup. Now copy the code back to Wolfram language. Run it. 7 solutions, all correct answer. So this is my this is close to my last offer. Okay, so let's modify more. 8th solution, shorter. Okay, now we are starting to manipulate the little variable names. Okay, so data just become x. Okay, and this first can be shortened. Okay, so actually let me just massively start to do things that you normally wouldn't know what I'm doing. Okay, so yeah, there it is, much shorter and shorter. Now let's see module. I don't think you need, if you only have one variable, do you need the first argument to be a list? I don't know, maybe. So anyway, 8th solution. Okay, so also here we don't need there's a lot improvement to be done. So first, so you can just say okay, 8th solution. So first x, then position that. Okay, run it. Fantastic. Copy the code back to Wolfram language, paste the whole thing, run it. Fantastic. Okay, now we are starting to just diddle with code, like syntactical change, like remove the spaces, remove the redundant spaces, but that's not really good. There are some more optimization to be done here because but that's it for today. Okay, so I'm gonna go offline and gonna work on this more, and let's see how good it is. Let's see if I can beat Python. So there's a lot more to do. So I need to continue code this, and I also need to write a program that generate arbitrary input for this coding problem. Arbitrary valid inputs, so that I can test this on a input that has a million numbers, because we need to know how fast it is. So then we need to do some timings, so we can run a timing on all these different solutions. I'm pretty sure they are progressive, like okay, let's pop this back to Emacs, and let's syntax color it. Let's show in browser. So here we have the Wolfram code, and we have many solutions. Let's magnify, and I'm pretty sure the progressive, the later ones are faster and shorter, but we need to time it. Okay, that's it for today. Bye guys. How many? I probably lost all the people. Okay, so yeah. If you like my stuff, donate. Okay, buy my Emacs tutorial, check out my donate Patreon me, buy my Emacs tutorial, my Emacs packages, my JavaScript tutorial, and stuff. Okay, or just Amazon me a cup of coffee or something. Bye guys. Here's a solution. And yeah, okay.